All right, we are working on section 5C, which is more about statistics. What is a frequency table? Explain what is meant by the categories and frequencies. What is meant by relative frequency? What is meant by cumulative frequency? So a frequency table has two columns. The first column lists all of the categories of the data, and the second column tells you how much they occur, which is the number of data values in the category. Explain what is meant by the categories and the frequencies. Categories are descriptions of the data, such as which grades students received on a test or the heights of the trees in the forest. They can describe qualities or represent counts or measurements. The frequency of a category is the number of data values in the category. The relative frequency is how often something appears, right? So it's the relative frequency of a category is the fraction of the data values that fall in that category. The cumulative frequency is the total amount of appearances of those data values up until a point. So the cumulative frequency of a category is the number of data values in that category and all the preceding categories before it. What is the distinction between qualitative data and quantitative data? So here, this is in categories, and here, this is in number, right? That's the shorthanded version. Qualitative data describes categories, while quantitative data represents counts or measures. Brand names of shoes is a consumer survey, and eye colors are examples of qualitative data. Heights of students and quiz scores are examples of quantitative data. Binning is when you put stuff in the categories by number. The purpose of binning is to analyze the frequency of quantitative data grouped into categories that cover a range of possible data. A useful example is grouping quiz scores with a maximum of 40 points in the 10-point bins from 10, 20, 30, and 40. The first bin has 0 through 9, the second bin has 10 through 19, and so on. What two types of graphs are common categories or qualitative data? So we're talking about bar graphs and pie charts. So we're talking about in a pie chart, each category corresponds to a wedge of a circle. The size of a wedge is proportional to the relative frequency, how often it appears. Pie chart. In a bar graph, the categories are clearly indicated along the horizontal axis. Over each category is a rectangle whose height indicates the frequency or the relative frequency of that category. Decide whether this makes sense or not. I made a frequency table with two columns, state and one label state capital. Here there are no numbers. It makes no sense. The statement does not make sense. In a frequency table, one of the columns lists the frequency of each category, which is a number of data values in the category. Decide whether the following makes sense. The relative frequency of B grades in our class is 0.3. That makes sense. So 30% of the grades are B's. That's perfectly okay. The statement makes sense. Suppose there were 20 people in the class. If 6 received B's, then the relative frequency would be 6 out of 20, which is 0.3. Decide whether the following statement makes sense. Your bar graph must be wrong because you have 8 bars, but there are only 3 data categories, right? So if there are only 3 data categories, why would you have 8 bars, right? So these numbers should match. The statement makes sense because there should be exactly 1 bar per category. Decide whether the following makes sense or does not. Your pie chart must be wrong because when I added the percentages on your wedges, they total 124%, right? That makes sense that your percentages in a pie chart should not add up to more than 100%. The statement makes sense because pie charts are used primarily for relative frequencies, so the total pie must always represent the total relative frequency of 100%. A professor records the following final grades in one course. Construct a relative frequency table for the grades. That means that you're going to put in the number of times this thing appears. This is going to be the percentage of times that is out of the total number of times. And this is going to be a cumulative count as we go on this way. So let's start. How many A's? So we have 3 A's. And how many grades do we have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 24. So we need to do 3 out of 24 for the relative frequency. 3 out of 24 is that, times 100 is 12.5%. So then 12.5% goes here. And then we've added up 3 so far. How many B's? 1, 2, 3, 4, 5, 6, 7, 8. 8 B's. 8 out of 24 equals times 100. All right, so we got to round. It says round to the nearest tenth, so 33.3. All right, so now my cumulative frequency, I had 3 and now I added 8 more. So total now I have 11 in this running count. Got tons of C's, 1, 2, 3, 4, 5, 6, 7, 8. It's also 8. Oh wait, 1. Wait, see, 1, 2, 3, 4, 5, 6, 7, 8. Oh, this one here, 9. That's 9. 9 out of 24. 9 out of 24 equals 37.5%. That gives me 20. D's 1, 2, 3, 3, 12.5%. 3 more on top of this 20 makes 23. How many F's? 1 F. 1 out of 24. Let's see what that is. 1 divided by 24 equals times 100 equals 4.2. Rounding to 1 decimal place. 4.2. Adding 1 to 23 should give all 24. The total is 24, and the cumulative is 24. Determine whether the following is qualitative category, quantitative number. The eye color is a category. The variable is qualitative because colors are non-numerical categories. 11. The responses of customers on the satisfaction survey that are rated from terrible to fantastic. Now, just because we decide to put a number on it does not mean that it is quantitative. These are just symbols for categories anyway. It's still qualitative because satisfaction is subjective, but we're still putting stuff in categories. Determine whether the following variable is qualitative or quantitative. The flavors of ice cream, that is still a category. The variable is qualitative because flavors are non-numerical categories. The breeds of all cats at an animal rescue shelter. Qualitative because breeds are non-numerical categories. The annual salaries of NBA players, that's a clear number. The variable is quantitative because salaries are numerical categories. Let's roll with this now. We got 5-point bins. So each one, we've taken these numbers and put them in the 5-point bins. And now we're going to count like we did before. The numbers from 95 to 99, there's only one, and it's 99. So that's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 1 out of 20. That's 5%. Right? Cumulative frequency is 1. From 90 to 94 looks like 1, 2, 3, 4. So that's 4. 4 out of 20 is 1 out of 5, which is 20%. So the cumulative, I need to add another 4. That makes 5. 85 to 89 looks like 1, 85, 2, 3. So 3 out of 20, 15%. Add 3 more makes 8. 80 to 84. 80 to, that's 1. 80 to 84. Looks like there's only that one. That's 5%. Add 1 more to this 8 makes 9. 75 to 79. 75. There's 1. And here's 2. That's 2. 2 out of 20 is 10%. Adding 2 more makes 11. And then 70 to 74, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. I guess we didn't have to add this up because we needed the rest of them. 9 out of 20 is 45%. That gives 20. And so 20, that's everything, 100%. The total is 20. Let's see, we can increase the view here. Let's see, zoom in. Let's see here if we can. So here we're starting off with 35 million, 22.719, so it's decreasing. Let's see which one fits. 35.5 is definitely not, I'm sorry, category A is 35.5. Make a bar graph. They want the bars in descending order, so it looks like this is the only one that's actually doing that. So from greatest to least. View, zoom in. Let's try this one. Make a bar graph for this data with the bars in descending order. Country D, B, H, X, T, F. Okay, so it looks like the orders are all right. So start off with around 12, then around 10, a little bit more than 9, 7.5, 11, 10, 9, 8, okay. 7.3, and then what's this? Around 4. It looks like it's this one. It looks like it's A. Let's see why these other ones may be wrong. That's 9 point. It's this one. Oh, F is not 2.3. This is more than 2.3. Let's look at this one. Why is it not this one? This one looks about right. And 4 point. What's wrong with this? X is, oh, is this 7? 1, 2, 3, 4, 5, 6. All right, so that one's wrong. And 2.3. This one's 12. This one's barely 11. This one doesn't even look like that one's right. So A it is. 18 and 19, you need to click on the data. Oh, they're here. Great. So 18 and 19, we can look at the data and see which one is which. Use the frequency table for the ages of recent award-winning male actors at the time when they won their award to construct the corresponding histogram. So a histogram is just, one column by the other, and they're both numerical. So let's do a zoom in here. All right, so 20 to 29 should be 0 actors. So the first bin should have 0, so that means it's not this. Okay. From 30 to 39, they should have 9, which should be roughly half. Roughly half of the 20. I like that. Okay. Oh, but so that means this one, wait, is this roughly half? That is roughly half. That's good. So from 40 to 49 should be more than half. Which takes, so 40 to 49 is this group. This is not more than half, right? 13. And 30 to 39, that is roughly 13. That's good. From 50 to 59, it should be 6. And this is the third group. I should say it's the fourth group. That number is not 6. It's B. Let's see here. Zoom in. Let's look at our data here, see what we got. All right, so 94 goes from 17, then the 53, then the 72, then the 120, 134. Okay, let's see if we can figure that out. So let's see, in 2012 it should be roughly 300. Everyone's doing, I don't even know what this one is. Okay, so we want to do this. What time should be, so if we have so we want to do time series, right? So that means that the x-axis has to be time. Okay, so that means that these are out because time should not be on the y-axis. Okay, so any other ones that make that mistake? Okay, great. Okay, so that now, oh no, this one's also wrong. All right. Okay. So let's see. So this one is funky because it's not going up and down like this, right? These are steadily getting larger, right? So they're going up. So it's not this one either. So let's see here. I don't think they're increasing like this. Let's see. 1753. Right, so this is more like it. It's C. Let's see if we can get an idea. Maybe it's in 2006. 2006, there are 183. 2006, this number is not 183. 183 is closer to 200. 2006, that does look like 183. That looks like it's C. The graph shows a straight line growth over the entire time series. Looks like a straight line. Got 38.1% Protestant. That looks about right. That's D, obviously. Fits the data pretty easily. What else can we say? Protestant, Roman Catholic. A. Most students identify as Protestant or Roman Catholic. Use StatCrunch with the data shown to the right. Percent of people below the poverty line. Let's see which one ranges here. It looks like the high is in 1960. This is the highest values in 1960, so it can't be this. Highest value should be in 1960. Highest value should be in 1960. They made that pretty nice. And which bar graph is that? Highest value is earlier. That should be this one. In the class of 100 students, 68 students received a B. What was the relative frequency? That would be 68 out of 100, which is 0.68. It was 0.68 because the relative frequency of a category is the number of data values, 68, that fall in a category divided by the total number of data values. Qualitative data. An example is ratings of restaurants because they would be based on subjective opinions. You have a table listing 10 tourist attractions and their annual number of visitors. This seems perfect for a bar graph. A bar graph would be most appropriate because the goal is to compare the number of visitors that go to the attractions. A bar graph could do this because it uses a set of bars to represent the frequency of each category. You have a list of GPAs of 100 college students, precise to the nearest 0.001. You want to make a frequency table for these data. Explain your reasoning. So we'll bin them correctly, right? So we'll do a group all the data into bins of 0.2 of a grade point Y. It's very likely that small ranges of GPAs will be easier to analyze than the individual GPAs would be. Histogram is a bar graph where you're comparing numbers to numbers. It's a bar graph for quantitative data. Hope it helps.